So now start the question number 43, in which a function fx is given: cos of 2 pi fractional part of 2x, sine of 2 pi fractional part of 2x, and we have to decide some options according to options of results for this function. In option 1 we have to find the period of this function, and because of we know that the period of fractional part of x is 1, and that's why the period of fractional part of 2x will be half, as well as fractional part of 2x in this part will also be periodic function with period half. And we can also conclude this result: fx plus half is equals to cos of 2 pi fractional part of 2x plus 1 by replacing the x equals to x plus half, sine of 2 pi fractional part of 2x plus 1. Now, because of we know that fractional part of x plus an integer will also equals to fractional part of x, that's why this is also equals to cos of 2 pi fractional part of 2x plus sine of 2 pi fractional part of 2x, and this is equals to fx. So the fx is a periodic function with period half as well. So that's why the option A is correct, and now the option B is wrong, because of in this option B period is given 1. And now for option C and option D, we know that fractional part of x is a discontinuous function on integers, but in this case the period of fractional part is half, and in the period of half fractional part of 2x vary from 0 to 1, and from 0 to 1, that's why, and we know that from 0 to 1, that's why the angle of sine and cos vary from 0 to 2 pi, and we know that sine is equals to 0 for all integral multiple of pi, and cos is equals to 1 for all even integral multiple of pi. That's why the function fx is continuous as well as differentiable for all values of x, is continuous and differentiable for all values of x. So from this result we can conclude that option C is correct but option D is wrong. So that's why for this question answers are A as well as C. Now that's the question number 44, in which there is a cubic equation x cube minus px square plus qx minus r equals to 0, and there is an information given in the question for roots of this equation, and the information is that there is two roots which are equal in absolute value and equal in magnitude but opposite in sign. So that's why let's assume according to the given information roots are alpha, minus alpha and beta. So from this equation and the pattern of roots, we can conclude that sum of roots alpha minus alpha plus beta is equals to p. So from this we can conclude that beta is equals to p, and sum of product of root taking 2 at a time minus alpha square minus alpha beta plus alpha beta, and this is equals to q. So now from this equation we can conclude that q is equals to minus of alpha square, which is always a negative number. Now from this equation the product of roots alpha minus alpha and beta minus alpha square beta is equals to r, and we know that value of beta is equals to p and value of minus alpha square equals to q. We can conclude that pq is equals to r. So the given options are option B is correct, pq is equals to r, and option C is correct, q is always a negative number. So answers of these questions are B as well as C. Now in the question number 45, there is a function given fx which is equals to p of x cube plus x times q of x cube. And given that px and qx are polynomial, as well as fx is divisible by x square plus x plus 1, given is fx is divisible by x square plus x plus 1, and we know that x square plus x plus 1 is equals to x minus omega and x minus omega square, where omega and omega square are non-real roots of cube roots of unity. So if fx is divisible by x minus omega and x minus omega square, we know that f of omega should be equals to 0, as well as f of omega square equals to 0. So let's f of omega will be equals to p omega cube plus omega times q of omega cube equals to 0, and because of omega cube is equals to 1, we can conclude that p of 1 plus omega q of 1 equals to 0. Let this equation be 1. Now also v of f of omega square should be 0, so p of omega power 6 plus omega square q of omega power 6 will also be equals to 0, and we know that omega power 6 will also be equals to 1. That's why p of 1 plus omega square q of 1 will also be equals to 0. Let this equation be 2. Now by adding of equations 1 and 2, addition of equation 1 and 2, there is a relation twice of p of 1 plus omega square q of 1 will be 0, and we know that omega plus omega square equals to minus 1. From that result, equation becomes twice of p1 minus q of 1 equals to 0. Let this be equation 3. So from here q1 is equals to twice of p1. If we replace this result in equation 1, this becomes p of 1 plus omega times twice p of 1 equals to 0, and from this p of 1 into 1 plus 2 omega equals to 0. We know that 1 plus 2 omega cannot be equals to 0, that's why p of 1 is equals to 0, as well as q of 1 equals to 0. So from here we can easily prove that the polynomial px is divisible by x minus 1, as well as polynomial qx is divisible by x minus 1. Now from these two results we also can conclude that f of 1 and f of 1 is equals to, f of 1 will be equals to p of 1 plus 1 into q of 1, and because of p of 1 and q of 1 0, f1 will also become 0. So all these results give that the polynomial px, qx as well as this fx are divisible by x minus 1. So from this we can conclude that options B and C has options C and D are correct. Option C, which is both px and qx are divisible by x minus 1, and option D, fx is also divisible by x minus 1. So answers of this question are C and D.